Happy Thursday, everybody.
Yes, happy Thursday.
On Thursday this time.
Yeah, we are at the normal time, normal show. Everything's ready to go, right?
That's awesome.
Good. Yes.
Always makes me happy when I don't screw up the dates.
Yeah. Very good.
Yep.
So what's going on with you, Nikki? What's
not much?
New?
Just remind anybody that's over in EU that I'm going to be in Amsterdam the 23rd through the 28th. So we'll be doing the OSS Summit, and we'll be doing AI Dev there. So doing a talk at each. So feel free to come by.
Very cool. Very cool. And I guess we should talk. VMware Explorer is, I think, less than 2 weeks away now. So if you're going to Explorer, you should check out all the Tanzu related sessions. I'll be there. A lot of our friends will be there as well. So check out Explore Spring 1 there, and then also Cloud Foundry Day in the EU later in October. So all things to look forward to.
Nick's easy to find. Just look for the guy with the overloaded backpack. He's easy to spot.
Hopefully, I don't know. I always say I'll lighten the load of the backpack, but it's always at peak capacity. So
I've never seen you lighten the load. I always see it just grow.
Yeah.
You're going to end up having to start taking an army duffel bag every time you travel somewhere.
Yeah. 2 backpacks. Yeah.
Yep.
Cool. Well, I guess on today's show, we have a pretty interesting topic. We're going to be talking some JupyterLab and Langchain. There's like Python apps running on Cloud Foundry on Tanzu platform. And that's, maybe typically something that, maybe more in the data scientist realm. So we're going to see how that kind of merges within the Cloud Foundry space. But I guess, we can go ahead and bring on our guest here.
Yep.
At the stage, we'll welcome Kirti back to the show. Good to see you again.
Hey, Kirti.
Yeah, good to see you.
And then we welcome Yannick as well. Yannick, this is your first time on the show, so thanks for joining and being a new friend of the pod. It's great to have you all here. So I guess before we forget, we should go with the first question for Yannick, right? Because it's right. Yeah. So do you remember your first CF push, your first Cloud Foundry experience?
Yeah, I remember it was for my a job interview for Pivotal 6 years ago, I think. So I came from a Kubernetes background, and so I prepared this a first demo for a job interview using cf-jupterlab-uv, so the version of Cloud Foundry that you can deploy on your laptop. So it was my first experience, and it was a good experience. I realized how it improves the developer experience compared to a solution like Kubernetes, for example.
Yeah, I think the PCF dev, it's a lot of people had started down that path, especially with the folks who've been around from Pivotal back in the day of as they discover Cloud Foundry and getting pretty prepped for an interview, that type of thing. So pretty cool to see another long-term Pivotal friend here back on the show as well.
Always amazes me about the Pivotal relationship. It's almost like we can start doing 7 degrees of separation from Pivotal. This is one of those companies that it's withstand, even though it's no longer a company, man. Everybody, at least knows somebody that worked at Pivotal, done something with Pivotal. And it's one of those things where the company brand just endures. It's awesome.
Yeah, very cool. I think we should bring more of that back, but hey, we'll see what happens. Cool. So I guess when we're talking, and we probably should start out with a primer on maybe JupyterLab and maybe Langchain really quickly. But when I think of JupyterLab, Jupyter Notebooks, I think of like the traditional maybe data scientist role. That's a tool in their tool belt where they're running experiments. Maybe this is a long-term tool that's been in the AI space for quite some time, even predating the generative AI or chat GPT, let's say, moment in time. So, I don't know, Kirti or Yannick, do you want to kind of give us a lowdown of, your take on what JupyterLab is and how you see it being used across the enterprise?
Yeah, definitely. As you said, Nick, it has been very popular among data scientists, but it has been around for a while, since 2001. And, I have spent about 20 plus years in the industry as a developer and architect. And from the beginning, we have seen this agile and iterative development, right? So for me, it's always been a quick prototype, work closely with the teams, do research, and show the results to the stakeholders, and then take it to the production. So fast ramp up and prototyping and taking it to the production at a faster scale. So from that perspective, Jupyter Notebooks shines when you're talking about the iterative development and showing it collaboratively to other teams, and then taking it to the production, showing it to the stakeholders before that. So this Jupyter Lab, it is a web-based interface that combines code execution as well as visualization and documentation in a single kind of environment. So you can write code and see the results immediately, and then your document your thought process all single place. Also, it's collaborative, right? So you can share it with other team members, get their feedback on it, and iterate. Also, this can be, we have seen the next generation version, which is Google Colab Lab, is also based on Jupyter Notebook interface. So it is using the notebook, the IDE. Basically, it has incorporated notebooks, where notebook is nothing but a file that you can create, and it has documentation, code snippets, multiple cells, where you can write documentation and also show the path, how you have written code, and then how you're going about it. So it is interactive, and also GPUs, actually you can add multiple customizations to that as well. Jupyter allows that. So this is kind of in a nutshell what Jupyter Lab is. It provides Python language support, and it's very popular. But there are other multiple languages support as well. So initially it started with R, and other Julia is another language, and IPython was the initial project, and then it got launched, taken over by Jupyter Lab, and then they converted it into Jupyter Lab and Jupyter Hub kind of portfolios. But Python is essentially a very popular language with Jupyter Lab. There is a kernel you can get started with, and we can show that as well. But there are other languages support because of the popularity that is getting added. So it's just a matter of, not a matter of, it is difficult, but at the same time, adding kernel support for the specific language, and then have Jupyter Notebook support that language.
Well, I definitely learned something new, because I thought it was specifically Python only. So I'm learning something already. So thank you for that.
Yannick, anything to add in that space?
No, nothing to add. I think I'm new to Jupyter Lab. I experimented it in the last 6 months, but yeah, it's very powerful to prototype your Python application, or even either your backend or your front-end application. You can easily prototype any small application, or even your first MVP, to demonstrate value of your application.
Very cool. Well, do we want to kind of get into some of the demos? I know that when it's been kind of talked about for a while of Cloud Foundry and supporting a workload like Jupyter Notebook or Jupyter Lab, and there's been some like custom build packs built throughout the years, and some like if you Google it, there's stuff from SAP, there's stuff from a while, because CS has been around for a while, and so is Jupyter as well. So there's different iterations, but I know probably some of the like persistent storage could have been somewhat of a problem when we talk about the ephemeral application workload. So I think there's some solutions that you have there as well, which would be interesting to see. So you just want to kind of get into the demo here and see, kind of talk through some of the work y'all have done and how we can use it within the Cloud Foundry space?
Yeah, definitely.
Okay. Are we good to bring your screen up, or?
Yeah.
Okay.
Awesome. Yep. So from the Cloud Foundry perspective, right, the Tanzu platform with the Cloud Foundry. So what we have done is we have deployed JupyterLab in the Cloud Foundry environment. So this is the instance that is already there. Now, what are the advantages of this, right? Deploying this into Cloud Foundry. First of all, integrated workflow benefits that you are going to get with this. So mainly any pre-approved LLM which are deployed onto platform, they can be connected with this JupyterLab instance that is deployed onto Cloud Foundry. Also, any data services connectivity. So if you have Postgres, Valkey, Gemfire, RabbitMQ, or any data that is deployed onto platform, you can connect this as a service binding to this cf-jupterlab and start exploring that data, connect to that data, and do feature engineering on that data, visualize that data as well. So there is a direct connectivity between these various service binding. That are the advantages of deploying this instance onto Cloud Foundry environment. So that is what I have done here. So you can see that this is deployed. You can view the app, and like I told you earlier, there is a web interface for the JupyterLab, right? So that is going to bring up the web interface for the JupyterLab. And then here you can really start coding and use this. So one more thing that I wanted to show in this JupyterLab environment, if I go into the services for this instance, like I said, there is this is a model which is Qwen 3 model that is deployed with the Gen AI tile that we have with the Tanzu platform. That is the service binding is provided to the JupyterLab instance. Also, I have some model context protocol servers, which are Time MCP server and Pet Clinic MCP server, which are also service bindings that are bound to this JupyterLab instance. And we are going to use that in our examples as well. But first thing actually is connecting to model. That's what I showed you earlier. But before we dive into that, actually I want Yannick to show the deployment. I just showed the deployment, right? But this is the repository that Yannick has put together to quickly get started and deploy this JupyterLab onto your CF Tanzu platform environment. And he's using UV, which is a virtualized environment for Python, and he has created a build pack for it. So that simplifies the deployment, also improves the speed as well as performance. So Yannick, if you want to just go and CF push how to deploy it onto Cloud Foundry environment, if you can show that real quick, that will be good.
Sure. So I will maybe share my screen.
Yeah.
Sure. Take your screen off, Kirti.
Do I have to stop?
And
we got you.
And while we're doing this, so the purpose of this, Kirti and Yannick, is this bringing development environment into Cloud Foundry? Is that what this is doing?
Yes.
So this is kind of a cloud development environment that's installed?
Yes.
Okay.
So
And the
think
next
of
question,
it as a sandbox environment for developers, right?
okay.
Yeah.
And the next question is, will each developer need to install or push the JupyterLab application, or will it be another instance when they want to use it?
Instance, actually, they don't have to deploy. So it depends on the organization, right? So there is a Jupyter hub that can be a centralized location that can be deployed, and each developer gets access to the instance. So it is multi-tenant basically. That's one way to look at it. Or to initially start with, they can deploy this instance that Yannick is showing, and each one gets its own access. So you can manage it at the organization level or at each developer level as well.
Okay.
So
yeah, go ahead. Yeah, I just it's pretty cool that we, my experiences, I guess, with Jupyter Notebooks and Lab is just more of like, let's get this installed on a VM and attach it to a GPU and then dedicate that whole VM and GPU to like an individual developer or data scientist. So it's pretty interesting how we've adapted the service binding construct here to kind of share that within the platform.
So go ahead.
Over to you. Sorry.
Okay. Now to deploy it. So usually, because it's a Python package and it's a Python library, we are using the Python build pack using pipe, but pipe it's pretty slow. So using UV, it's a new package manager for Python. So one of the main benefits from UV, it's very fast. So it means that the building time will be reduced using this UV. So to deploy this Python application, what I did is I created this UV build pack to just leverage UV to deploy this to deploy JupyterLab. And to deploy JupyterLab, you just need to create your project with your dependency. So dependency to the JupyterLab package. Here we are adding the JupyterLab Git to be able to use Git within JupyterLab. And here I will add my different dependency for my Python project that I will develop within JupyterLab. Just to show you, for example, a sample of, for example, of a notebook. So a sample code that will be able to open within JupyterLab and run it within JupyterLab. So here, just create a manifest. I'm just using this UV build pack. I'm just binding this JupyterLab to the same model that Kirti showed you, and I will do a CF push. And just to show you the speed of the deployment, I will just time my CF push.
Oh, look at you! I like it. I like it.
Getting fancy.
Yeah.
And so it's push in your existing environment, and you will see that here it will upload the artifact. It will start. The building time is very fast because at the end it's just installing UV, and here it start to download the. So you can see that install UV, and here it will start to install the library. And what I'm doing is I'm installing the dependency at the starting time, because UV is very fast. You can do that at the starting time.
Yeah, it's like a virtualized environment.
Very cool. I'll have to try this out with the with Open Web UI, because I know they support EV install, but we were using the I guess the older pip-based Python package, and it takes a long time to push. Yeah.
And, earlier, actually, even this install, I tried it without UV. It took about 6 minutes, and with Yannick, just came up with this fix 2 days back, actually. So this UV, it has been few seconds.
So as you can see, it took like 55 seconds to CF push this project, installing all the dependency. So it means that now I can access my JupyterLab environment. So let's do that.
Very cool. This is we need to like put this in the core CF project. This needs to be like an official build pack for Python.
And so awesome. Here I can have access to my code, and I can start to develop my application.
Yeah.
And just to show you some numbers, so same project, same dependency, using the Python build pack with pipe, it took like 6 minutes to do the same stuff.
That's that whole, it's just the build pack stuff we're talking about. If you're doing anything with Python based apps, I think that's a very very important detail here.
So really the difference is between using a pipe as a package manager for Python and UV that it's written it Rust, so it's by far faster than pipe.
Now, is there a way to like store all the dependencies locally if you're like in an air-gapped environment, or is that another additional thing
it's another question, but you could eventually.
Okay. We'll have to explore that more. But yeah, this is phenomenal. I want to try this on Open Web UI after the show, because it's like it was getting to the point where people were trying to deploy it, and it's like, well, it's past the default 15-minute timeout for CF push, so it's like, this.
And I know with a lot of Python, the dependency management is an issue. Is that where you're setting that within your dependencies to start about which version of Python you're using and any dependencies that come in? Is that where that comes in?
Yeah, exactly. So all my dependencies are listed there. So this is what the build pack is using to deploy all these dependencies at the startup.
Okay.
Very cool.
Yeah, very cool, actually, right? I mean, that's how UV, if you can bring up the other screen back up.
Sure.
Yeah.
And so you would want to deploy this if you're using different versions of Python. You would want to deploy an instance for each version based on that dependency list, and then entitle those. Or can you build like PyEnv something like that so that they can move it around?
It's using Python 3 right now, but Python 3 kernel. That's what. So you can, for different versions of Python, actually we can add that as a dependency. So these are the kernels available, right? Python 3. So you can just open that and start using.
Gotcha. Okay.
Yeah. And this is what I have done, right? Created some of the samples here. Mainly, I wanted to experiment with Langchain and LangGraph. So if you haven't heard of Langchain and LangGraph, these are the frameworks in Python for developing agentic applications powered by large language models. But they kind of differ in their approach to workflow orchestration and management. So I have just put together these samples here. Let's try to take a look at one sample. So let's bring up this Langchain agent. First of all, this is a simple application. Mainly, what it is doing is it's using a time tool as in the agent, registering that to the agent and trying to get the today's date basically.
Could you zoom in a little too? Sorry to interrupt you. Just for anyone watching, maybe zoom just a little bit in.
Should I zoom in?
Yeah, like a command plus, perhaps.
Yeah.
Just to get a little. There we go. Yeah. Sorry to interrupt.
No worries. All good. Yeah. Okay. Okay.
Slack really wants to update.
Yeah. Yeah. So here, this is a Langchain agent, and what I wanted to show here is connecting to a deployed model with the VCAP services. And this is a code snippet that we are providing out, in this in these samples, where I'm trying to discover this VCAP services. VCAP services is nothing but the environment variables in the Cloud Foundry environment. And I wanted to discover the chat model, the Gen AI services, and get the credentials. So that I'm doing it programmatically because this is, and then setting it to my LLM. So the chat open UI is provided by Langchain, and it provides open API endpoint access with this chat open AI interface. And I'm kind of initializing that and setting up the model, base URL, and API key, and HTTP client. These are to initialize the LLM access. So this is done programmatically by discovering all the services through service binding and VCAP services. Once I do that, I define the tool. There is a tool decorator in the Langchain where you can, this is nothing but a simple function right now, but it can be any tool. It can be model context driven protocol, remote server that can be connected as well. And I have a sample for that. But here I'm using Langchain decorator for tool to define this time, tool, and then creating the list of tools for my agent to consume, and then defining or initializing the agent. This is simple Langchain framework provides you this kind of way to define and initialize the agent. So pass tools, LLM, any agent handle, etc. All these parameters, define the agent, and then have your prompt, and then print it out. That's a simple Langchain example that I have here. And you can run it because this is interactive environment, and there you go. So I'm using Quen 3 model here, and basically Quen does this thinking part before. So this is the output that is generated, and before it provides the final output, this is the process it went through, and then gave me the final answer. So because I have set verbose true in my code, I got all this trace. How did model go about? So there is, Quen goes through like the thinking process before, and spit out the final result. So this is how interactive it is. You can basically add comments, and define this code, and with the Jupyter notebook.
Oh, very cool. And I like how we're showing how you can how LLMs are becoming more advanced with the use of tools. So that's pretty cool, right? And no one picked up on that. If you asked that Quen model what the current data is without that tool, it would have been like, I don't know, I have no idea, right? So that's cool. But I could see how this is how this type of tool has been very popular in like the data scientists kind of like experimental type role for for a long time now. So yeah, pretty interesting how we can just basically write some code snippets and execute it. And I can see how that flow kind of derived from like, let's run experiments and see what the result is type of thing. So that's pretty cool to see that here running in Cloud Foundry.
Yeah. Another important thing that I want to because now you have started coding, right? But you want to save your work, and you want a direct integration with GitHub because you don't want to lose what you're doing here. So this is we have integrated with GitHub as well, and this is in the requirements.txt. As you can see here, I have added JupyterLab Git package, and with that you get integration with the GitHub. So this is what I have done here. You can clone a repository, and this is a sample repository that I have put together for CF JupyterLab samples. You can just add it here. I already have cloned it, but just to show you, this is how you can clone a repo and get started. I'm going to cancel that, and already I have cloned it. I'm going to open that up, and just make some changes in this file. So yeah, and I'm going to save that. Also in the Git, I can add it, and it's the entire and add the comments. So as you can see, this Git interface, the stage changes are shown, and just a sample here. and commit.
Are you saving your GitHub credentials like in a user provided service or something, or how we? Oh, never mind. I see.
Yeah,
Never mind.
Just needed to wait 10 seconds.
How's it authenticating to GitHub? Question. Yeah, I see.
Yeah, exactly. So basically, yeah, it will ask you. But if you have your enterprise GitHub, you know, you can do that as well.
Very cool. All right. I mean, this is a really interesting flow of how you could, use these notebooks. I guess really lab as a just, a place to, test code. Like, I could see this being interesting too. If like, hey, I need to, because I deploy a lot of different models within the Kuhn Labs data center. I'm like, hey, I could just use this to have this some kind of up persistent, and easily swap the model binding out and just like run, kind of, like, here's my test suite of commands to see like, is this model any good at this type of thing?
Exactly.
Type of thing. Yeah.
So this is how GitHub interaction can be achieved. As you can see, the code is pushed 1 minute ago into this.
Very cool.
So yeah, I mean, this is how easy it is, and you can save your work and have entire GitHub flow with that. A few more samples I wanted to touch base on is, and then I can pass it on to Yannick for further. This is a chain pattern, right? In the Langchain, this is a simple chain, so where you can chain the LLM and various prompts. And in that prompt, actually, you can use different models as well, right? So it's the multi-model that you can use, or dynamic prompts can be used as well. So here I'm using the same pattern again that I have defined earlier, where I'm discovering and registering, creating the LLM, initializing the LLM with the model, and then this is a prompt, and this is a dynamic prompt. So I'm creating a chain and then passing it, find me a product from queen size sheet sets, for example. And then response chain.run product. This is a pretty small example how the chaining through the Langchain can happen. But this is one of the workflows and the pipelines that you can create. And I can run it and again see the response. So here it's going to go through multiple thinking process here, as you can see, and it's going to spit out. And here is the interactive way where you can see the output, also see if you put the verbose true, you can get how many tokens are used and how many the prompt tokens are passed, and different stages as well. This is another pattern, which is the router pattern. So router pattern is a way to direct a user's query to the most appropriate subchain. So for example, I have created this multiple chains here. So there is a physics template, there is a math template. These are nothing but the prompts, right? Different chains. And then I can create, based on my multi-prompt router template, I wanted to just pick the right chain. So this is, this one particularly, chain.run, what is the black body radiation, for example. So this is a physics prompt. So if you see in the output, this physics path is picked, so I have created multiple chains and it is routing to the right chain, basically. So it is similar to the tool pattern, but there is a little bit of difference there. This is programmatically, I'm defining this multiple chains, and then it is programmatically picking it. In the tools pattern case, it is basically LLM chooses the right tool for the right job, right? So that's the difference there. But this pattern is available as well in the Langchain. Yeah, so these are a couple of examples that I have put together. And another one is just to point out is, how do you integrate MCP servers into Langchain? So this is the one example that I have put together for MCP server. Where similar way, right? So discover the services, initialize LLM, and then instead of the tool that I had defined earlier, I'm not going to use that tool. Now I'm going to just use the tool which is bound to this cf-jupterlab. So I'm going to discover the tool as well. So here is a code to discover the tool. So for example, there is a pet clinic MCP server, which is service binding is created. This is a user provided service. I am trying to filter those with the list that I'm getting back, and then getting the credentials for that MCP server URL, creating the URL. Somehow I need to add SSC at the end of it, and then pass it to my tool list. So here I'm creating a tool list with the time MCP server, pet clinic MCP server, for example, which are discovered. And the URL is where from the service binding that I'm calculating and passing it. And here I can discover all the tools and then start using it. So here I just have a program to spit out all the tools which are registered with this agent, and these MCP tools are registered to the agent, and then I can start using it. So this is how you can connect a Langchain code with the MCP servers which are deployed onto platform. So we have a sample for that as well.
So a silly question here. So if we're binding, are we binding the MCP servers when we deploy, or okay, so you are binding at deployment of this, and then you've got to go into code and then re-register.
No, these are already bound. Actually, these are already bound. I'm just discovering it in the code.
Okay.
Yeah. So like you start, you push JupyterLab as an app, and then you say like, here's my services, right? And they're going to be like any of these little code blocks that you want to run. You can just call VCAP services, and it'll be available, right?
Yeah.
If I okay. So like this might even.
Idea. Yep.
Yeah, this could be an interesting tool too. Like, could you do like I know sometimes where we talk about data on platform, and if we don't necessarily have the TCP routing enabled, like getting like I need to access like a Postgres. I want to run some like PG commands or something to the database. Could you potentially do something like this with this instead of trying to like? Yeah, very cool.
Okay.
Cool. So I don't have to worry about trying to deploy PG admin again. I could just use this to like drop a table and rerun my test or something like that, or modify a table or something. Very cool.
Yeah. One more pattern actually, and then I'll pass it on to Yannick. But Lang graph, right? I showed Lang chain patterns, which is a router pattern, simple chain pattern, and things like that. But Lang graph actually, so more of the linear operations and linear cyclical things, Langchain is better for that. So you have multiple chains of prompts and LLM interaction, right? But more complex pattern and more if-then conditional statements and more complex operation. There is a Lang graph framework that is provided in Python, and it is based on Langchain as well. But it allows, complex operations with agents, multi-agent patterns as well as connecting memory and stateful operations. Those are possible with the Lang graph as well. So this is one of the examples that I have put together. So Lang graph has a concept of nodes and also edges and connectors. So mainly I have defined that, this is nothing but again, the same pattern, recap services, define the LLM. This is my model initialization. I'm using some memory as well here. Just a simple in-memory sequence saver checkpointer that I have created, and I'm binding that. But what I wanted to show, and probably it is not here. Okay, here. So building a graph, right? So basically, I am building multiple nodes, conditional edges. Conditional edges is nothing but the data flowing through the graph, and then just different edges to connect this. So mainly, my graph looks like this for the particular thing that I have, a particular agent that I am working on. There is a sorry. So I should show this example right here, which is a essay writer agent that I have defined here. So for this particular, actually, I'm building a graph with different, plan and reflection pattern. So here there is a plan prompt, writer prompt, different prompts that I have defined. And then I start building the graph, and then get the answer from the agent. So here I'm building the graph with the planner. Then there is a generate node, there is a reflect node, there is a research plan node, and there is a research critic node. So to write essay, I'm going through all these different phases, or different phases, and then coming up with the answer. So that's going to give me accurate answer. And the simple diagram for that graph looks like this. There is a plan phase, that's the initial phase. Then there is a research plan, there is generate. Then here is a conditional loop where you can continue or end after generating. And if there is a critic, it can go back and regenerate. So if user provides any critic after research, it can go and regenerate. So this is one of the agent pattern that I have defined here, and there is a sample app for it. And you can run it in the JupyterLab and see the output. So for example, this I ran it couple of minutes back, and I see generated essay, and how many iterations it went through, and things like that. So this is one of the complex example, but there is a sample for it as well.
I think it's pretty cool, because it's like, if I understood that correctly, you're having it generate this output, and then having the model kind of like evaluate what it did, and like, are you sure? Right. Like, maybe we want to run that again. Like, and like, all right, let's try to use it to get like the most, the best run possible, or the best.
Now, is it doing this automatically, Kirti? I mean, is the model reevaluating itself, or is this based on human input critiques?
It's doing it automatically. And only the research critic part, actually, it doing it after user input.
Gotcha. Okay, so when it does the regenerate would be based off of human critique.
Yes.
Not LLM critique.
All correct.
Yet.
We
can wire another model in to see how it feels about the other model's response, right?
But this is one pattern that I have put together, and there are multiple of those. But here are some examples, which is plan and execute. That's one pattern.
I do think that would be an interesting thing to do, Nick, is to have another model critique what this model put out. It would be interesting to see what kind of loop that creates, right? As the two LLMs start arguing with each other about what's right and what's wrong. That would be an interesting little side project.
Right. Well, and then I don't know if you noticed, so like I call it a SQLite, and I'm feeling Terminator vibes again. So if you didn't watch the show last week, V and DMZ were on the show, and they're talking about just very, very briefly. You should watch it. Last week. It was great, but there is a CVE found in I think out of the SQLite code base, but I think like Google DeepMind predicted the CVE was going to happen somewhere in the SQLite code base based on like some heuristics or something, where like the LMs are starting like I see like this sloppy code in here, like surely there's going to be CVE in here. I'm gonna keep scanning, that type of thing. So like I saw that, I saw this loop stuff in SQLite. I'm like, this is, well, we got all the pieces falling together here, where like, Terminator happens, and
very minority report. Predicting the future of CVEs through LLMs looking at themselves.
Very, very crazy. So yeah, let's chain all the agents and LLMs together and see what happens, right?
Yep.
Right.
Cool stuff.
Yeah, so this is LangChain and LangGraph kind of patterns and how you can incorporate Cloud Foundry service bindings and get the services connected and test. And then evaluate the model. So evaluating and training and prototyping becomes easier, right? Because it's all handy. Yannick has a cool demo as well. Yannick, you want to?
Yeah, so can I share my screen, I think?
Yeah, we gotta take Kirti's off. I mean, if that UV build pack wasn't cool enough already, I mean.
Yes.
So let's see what we can do with it. So share. Do you see my screen?
I think we're getting there. All right, here we go. Oh.
Here we go. So we're back to this application. So here, this is my existing JupyterLab instance. And so let's go back, for example, to a simpler notebooks. So for example, here, the same binded services. I'm using the same way to discover these existing services and to get access to the URL of this LLM. And so here, for example, I will just build using the same OpenAI library. I will build, for example, an assistant that is great as TeleJunk, for example, for an audience of Cloud Foundry enthusiasts. So let's try this prompting.
I like jokes.
You like jokes? So let's see. Let's see.
Yeah.
So here we are seeing the thinking, but let's get to the joke itself. So why did the Cloud Foundry developer get promoted? Because they are a real build pack of talents. Not bad.
Yeah. I like the reasoning models too. When you ask it the joke, that it's sometimes funny to read the thinking part, but it's also sometimes terrifying to see what it's thinking to tell the joke. So it's pretty interesting to see that output there.
I'm seeing a nice theme between droplets and build packs. Almost every one of its jokes.
Yeah.
So we saw that it's good to prototype, for example, backend. So let's do something more visual. So for example, I would like to start to work on my dashboard, and I would like to, for example, to create some charts from existing data. So let's take, for example, another piece of code. So I will go back, and for example, I will use this matplotlib library that is made, for example, to create some chart. So
like
I will
like visual dashboard of some type.
Yeah, exactly. A visual. So matplotlib is this library, so you can create this kind of visualization for your data.
I'm learning so much new stuff today. I'll be honest. This
So
is a great lesson for me today.
So here I will just create a new cell. I will paste my code, and so what I'm doing here, I will not declare again my OpenAI models because it's already there. It's already created there. So I will just reuse this one, but I will give you another roles to this. To my prompt. So here, for example, I will try to create a dashboard, for example, for an application that will list my applications that run on Cloud Foundry. But for now, I haven't integrated yet my my Cloud Foundry API to my application. So I will ask the model to generate this kind of information. And I will ask him to, for example, to generate JSON files to be able to pass it to my matplot library. So here I will ask him to generate 5 fictional Cloud Foundry application. and I will ask him to answer me back with, for example, a JSON file with app names and with, for example, with fake data. And so when I will get this answer in JSON file, I will parse this information, and I will use a matplot library to create this nice visualization of it. So let's try to run this piece of code.
Cool.
And here I have an error because why? Because I don't have this matplot library in my project.
Oh.
So I could add it in my project and restage my application and or do another CF push. But what I can do with UV and with JupyterLab is to just go to a terminal and just add my missing library using a UV pipe install.
Oh. Well, this is pretty cool.
Yeah.
And it's installed in less than 1 second. And
Yeah.
so now I can go back to my project and try again.
Yeah, so you don't have to restage or restart. The app,
Very cool.
Which is cool.
And so let's see what the model will generate as fake data and how it will be generated using the matplot library. And so here I have some information, and let's set those bars. And so yeah. So I can start to prototype my future dashboard, for example, with my application. And when I will integrate my CF API with my application, I will be able to display this information as is.
Production staging development, yeah. Auth gateway, instance count. So it's knows instance count. That's right. You got the memory usage in megabytes. Yeah, that seems right. Oh, very cool. Nice. Oh, we got the little output here too.
Yeah.
We got yellow, green. Oh, this is very
I
cool.
do like the summary.
Yeah.
So the idea, yeah, you can use the EV pipe install to quickly add a new library that has not be part of your existing project. So
I was going to say that this would be a great tie-in for the memory shame plugin that we talked about a couple episodes back, but that's getting kind of built into Hub. But this would be a great way for somebody to go in and kind of automate some of the platform engineering to give a dashboard of people that may be, abusing the memory system or doing other things within the foundation that the engineers don't want them to do.
Yeah. I mean, I think with the possibilities are endless here. You could be, you just use this as it's really cool to think of that you have this system that you're able to use like all of the CF binding services to, where like I just need a database and I just need a cache, and you could just inject that all into VCAP services, and like, hey, like now I can just like test some code with this Postgres database here and make sure like that's working, right? And then now it's like, okay, well then when I know to like push it for real as an actual app,
right,
it's like it's gonna work, or like it will be at least closer than what I would have gotten trying to write it without any of this, right? So, yeah, very cool.
And for example, another use case, you define your backend logic, but you would like, for example, to start to work on your front end and your user experience, and how you could do that with JupyterLab. So you can, for example, use a front end library to generate a front end to be able to use your existing backend running on JupyterLab. So, for example, we'll use a project called Gradio. So Gradio allow you to create a single page application very quickly without knowing any HTML or JavaScript. So the idea, you'll be able to develop your front end in Python with a Python framework.
Yeah, so it's a Python library called Gradio, and there is also a Streamlit library that you can use.
So let's try first to install.
So almost pre-prototyping.
Yeah. So let's try to, for example, to install this dependency. So it's there, and so now I will, for example, take another piece of code, and it will be a front end for my Joke Assistant application.
And then like the front end and the back end here are all really just running within this app.
So let's create a new cell and let's paste my code. So here, as you can see, I import my Gradio library, I just defining a function for my front end to be able to, when I will submit my prompt, it will automatically be posted to the backend. And here I start to declare how I want to represent my front end. So here I want to put a block on top. I want to add this markdown. I want to create a button to submit my prompt. I want to create this text box. I want to manage how I will manage my answer to display the answer into this text box. And here I'm linking my function to my button. And here, for example, on the bottom, I want to avoid to type every time the same stuff. I want to give some example. And here I will expose this front end into this port, and let's see what's happened.
And when this goes, I think I might have saw something where you did some constraining on how many tokens that this could use. Did I see that up front? Or?
Yeah, you can put this kind of restriction. So here it generates my front end based on my declaration. And so here, for example, I can access quickly to this front end and start to ask some joke about Cloud Foundry. And so send.
Very nice.
Nice. Very cool. How's that doing the routing there? Is that like
it's an API. It's an API from Radio. So yeah, I still have to troubleshoot. Let's try another again because I have to parse the answer. So yeah, it's working. So now you can start to interact with you.
Too many layers. Nice. That's a good one.
And so yeah, you can see I'm removing the syncing answer. I'm just pasting. I'm just displaying the final answer. And so this is how you can quickly prototype also your user experience and your front end using this kind of library within JupyterLab.
Nice. Lots of prototyping here. I think it's cool. You just kind of you just keep adding blocks within the same kind of window. And all right, I've simulated my back end. Now I'm going to simulate this front end. Does this even work? Yes, no. Oh, no. Let's change how it looks there. Quick.
And as you can see, I just had a new block. I never redeclare my OpenAI's LLM.
Oh, because it's all chained from above, right? Yeah. Yeah, I mean, again, the more I watch this, I get why this was such a big deal in the data scientist community for so long. Yeah, and how it's kind of becoming more into the development community, like the traditional development community.
Yeah. And so with UV and with the terminal, I was able to in live without restaging or restarting my application, just add new library I need for my development.
Awesome.
Very nice.
Well, I mean, this is I maybe go back. I've been working on this Gen AI, tile thing for a while, and at one point in time, we were talking with a customer, and we had a developer come in. It was like a data scientist developer. He's like, "All I really need is a VM with a GPU and Jupyter Notebook." And I was like, at the time, we didn't quite have this, but this could have just been like, here you go, here's the URL, and you have your GPU and your notebook ready to go, and everything else that the CF marketplace could offer at your fingertips. Very cool.
Yeah, it's almost kind of numbing of the mind to think of how many different ways you could take this. You know, what you could do, you could use it. I mean, it's almost a little bit of an overload until you probably get into it and start using it.
Yeah.
I can imagine the use cases are just all over the place with different examples of within like the data scientists or like, hey, I'm thinking like, well, now I can write like a suite of scripts that to test all these different models and like score them and like benchmark them, so to speak, without just like, I need to push this app, or you could just iterate like, hey, I want to deploy 10 models within the AI tile, right? And then iterate and then bind and use a new multimodal binding capability, and then just iterate through every one and then run this suite of like test and question and then like score it and then pump it into that graph and say, hey, what model is best at the hallucinated the least, or like answer this question the best type of thing. So
and we talked about this, Nick, when we were talking about all the different models that were coming out, and I can't remember the guy's name that goes through and does the evaluation. Makes you wonder, is he using something like this right now? Probably, I would imagine. I think all these
I'm almost speechless with how much I've taken in today. I didn't expect to learn so much today. I knew a little bit about this, but this is pretty awesome work. I really appreciate Kirti coming back on the show. I think for the third time now, right? And Yannick joined the show for the first time. So
yeah,
we'll have to have you back on. Yeah.
Yep. And we'll throw it out there to the audience. Was there anything that wasn't answered on this? Make sure you throw it in the comments, and we'll make sure we can get those answered, because I think there's a lot of possibility to this. I won't say there's a lot of possibility. There is a lot of potential to this. People much smarter than me will be able to do amazing things.
Yeah, we'll keep on building phase 2 for us as well. I mean, the more agents example, multi-agent examples, and things like that. So yeah, it's exciting.
Very much so. And like Nick, I'll echo. I learned some things I didn't know today as well. So appreciate that.
Yeah. And without further ado, we'll go to our segue to our sponsor, that you should not forget to like and subscribe to everything you saw here on Cloud Foundry Weekly on our YouTube channel. Eventually, I will publish the podcast audio versions of these, although I'm very behind. I apologize.
Well, this one's going to be hard for an audio podcast, but
yeah. But people do subscribe and download the audio version still. I don't want to exclude that audience still, but I'm sorry, I'm running behind there.
You're going to want to watch the videos to see everything that Kirti and Yannick did here.
Yes.
But absolutely. Yeah. And that's why you want to hit the subscribe bell. You want to know when these new things are coming out so you can make sure you can get on. And a big shout out to all of our guests that are watching on the CF Weekly Twitter. We hit some high numbers on the Twitter again today, so appreciate that.
Yeah. And it's still growing. So if we'll keep talking as it keeps growing, but we'll eventually have to wrap up here. But yes, I guess with that being said, any kind of closing thoughts that you want to leave the audience with, Yannick or Kirti, anything you're excited to see going forward, or anything like that?
Yeah, no, great. I mean, it's just we showcased JupyterLab on Tanzu platform, CF environment. And even when I started researching it, I did not know I will go that far, building more and more examples. So yeah, I mean, the smart prototyping, just start quickly, prototype, show it to the stakeholders, collaborate with the teams, and then take it to the production, right? Taking it to the production is, again, you have to take that, convert it into Python application. And it should be easy because you have already tested it with all the dependencies such as LLM, as well as data that you are connecting to. So it's already bulletproof. And then you're taking it to multiple stages. So it becomes easier. You are simplifying your workflow. So yeah.
Awesome.
That's Yannick, anything?
No, 6 years ago when I started with PCF Dev, I was thinking that Cloud Foundry was a great platform for developer, and 6 years after, I think this is still the case, and even more with AI. So.
Very cool. Very cool. I think we tend to agree with you there on that one for sure. Yeah. And also, if you have links to your, if you want to share any GitHub repos, let us know. We'll get them in the show notes and in our YouTube posting and things like that, so you can go there and grab the sample repos. If not, if anything, I want to get my hands on some of this already, and I think I'm going to clear up my afternoon and start running some tests here, and see what I can get up to with this.
Nice,
very cool,
awesome.
All right, final pop quiz for Yannick. Since you're new to the show, do you know how we close the show?
No.
It's okay. No one's ever gotten this far. No one ever gets it. No one ever gets it. We close the show with a CF by. So I'll count down 3, 2, 1, and we'll just CF by, and then that'll be the end of the show. Okay. So now you know when you come back how we close out the show. All right. With that, 3, 2, 1,
CF by.